Right. Good day, everyone. So today we'll be having a new lesson, and in this lesson, you will study how to illustrate and solve problems involving angles of elevation. You'll be given an opportunity to do activities that will help you identify and define angle of elevation through illustration. Also, you'll learn that in solving problems, you need to draw a detailed diagram to help you visualize them. Those concepts that you have just learned about right triangles and trigonometric functions will help you to get through the next lesson. So, as a recap, sine, cosine, and tangent are the three main functions in trigonometry. They're often shortened as sine, cosine, and sin, cos, tan. The calculation is simply the length of one side of a right angled triangle divided by the length of another side. We just have to know which sides to use, and that is where SOHCAHTOA helps. For a right triangle with an angle theta, the functions are calculated this way, as given in the screen. The other trigonometric functions of angle theta, which are the reciprocals of sine, cosine, and tangent, can be correspondingly and mnemonically written as CHO. So these options can be, since they're the second one are just the inverse one. So reciprocal. You just have to choose which one you want to utilize with. Um it's not a requirement. So again, we're going to learn about the angle of elevation, and learning targets will be: first is for you to define angle of elevation. Next is to solve for angle of really solve for solve problems involving angle of elevation. So consider the situation here. Suppose that an airplane takes off from a runway of an airport and flies along a straight path to reach a certain height. Does the path of the plane make an angle with the runway? Is it possible to find directly the distance from the point where the plane takes off to the end point of the runway when the plane is directly above it using a ruler? To answer these questions, there is a need to understand first the term of angle of elevation. It is widely used concept related to height and distance. The trigonometric functions, as you have learned in the previous lesson, will help you answer the following problems. First, what is an angle of elevation? It is of an object as seen by an observer is the acute angle formed by the horizontal line. If you see in the illustration here, horizontal line is that's the level, no? Or we say it as the eye level. That is where, like, when you stand up and then you look like straight in front, that's your eye level or horizontal line. And the line from the observer's eye to the object line of sight, say the airplane we're talking about a while ago, it is located higher than the observer. Where is the angle of elevation there? That is where that is in between the line of sight and the horizontal line. So if you see the angle theta here, this part here is the angle of elevation. So usually when you speak about angle of elevation, you it's like you're looking at something above. Okay, that's the short way. You can see an observer on the ground who's looking at the object located higher than him. And angle theta is formed by his line of sight and horizontal line, which is the eye level. This angle is called the angle of elevation of the object. This one is another illustration in which you can see the angle of elevation. When you stand up, that's your eye level. This part here, the horizontal, is the eye level. And this one is the line of sight. Okay. Line of sight. So eye level, that is like straight path. You're looking in front, and then when you look up, that's your line of sight now. Okay. In this case, we now create a figure that is of a right triangle. And with that, we can then apply the concept of the sixth trigonometric ratio, SOHCAHTOA CHOSHAHCAHO. You may also consider the following reminders in determining the function to use. If the measure of either leg and hypotenuse of the right triangle are given, then sine or cosine function may be used. If the measure of the legs of the right triangle are given, then tangent function is to be used. Okay? Again, these are like the options. But you may also use the secondary one, the CHOSHAHCAHO. The given are leg and the hypotenuse, wrong spelling. You use either sine or cosine. And then if it's legs, the two given are the legs, you use the tangent. So let's apply it. Let us have some situational problems that involve angle of elevation. Proper understanding and interpretation to the problem is necessary for you to come up. And just a reminder that not all problems will provide you the illustration. That's why there are times that you need to provide for yourself, and of course you must assess your drawing before you finally say that it is the um, right illustration. Well, there might be right illustration, but the proper labeling is not correct. Then you will still end up with the wrong answer. So here, this one is a given one. So let's try this. Again, when you apply the sixth trigonometric ratio, this is still of the same concept. But first, you need to assess what kind of what kind of function you're going to use. So the first problem, a tower is 15.24 meter high. Now we're talking about problem solving here. We have to write the final answer in sentence form with the proper unit of measure. At a certain distance away from the tower, a man on the low level ground observes that the angle of elevation of the top of the tower is 41 degrees. How far is the man from the tower? If you see it here, this is the building, and then it is, or the tower, and it is 15.24 meters. That's the height of the tower. And then you have there the man's line of sight. So let's say the man is standing here. Up here, that's the line of sight, looking up, and then the eye level is somewhere here. Question now goes, how far is the man? So basically, the eye level or the level ground is being asked, this part here. So now we make the illustration there. So take note the X is for this part here. Okay. So the 41 degrees is between the line of sight, the eye level and the line of sight. Let's say the person is standing here. So the line of sight is going up there, and then the eye level is this part. So this is the angle 41 degrees. Okay. Where do you start with that? So of course you need to assess what kind of function you're dealing with. So in this case, you have to look at the relationship of the given sides to the angle you have. So this is the angle, the reference angle. We usually use the word reference angle. And then you look at this side. This is the opposite side, and then this side is also the adjacent. Now, as in the reminders, if the two legs are given, you must use tangent or cotangent. So let's start. So let x be, I'll use a different color. We're writing in a, let's say let x be the distance, The distance of the man. I'll just cut it short. Adjacent side to 0, so 41 degrees. So we will use tangent theta because the given is opposite leg, adjacent leg. Tangent theta equal to opposite over adjacent. Just then simply right there, tangent 41 degrees equal to 15.24 over represented by x. I'll rewrite it here. Tangent 41 degrees is equal to 15.24. There's no need to write the unit, but if you want to, it's possible. So then you do cross multiplication. It is 15.24 over tangent 41 degrees. Roughly, that is around x equal to 17.52 meters. Okay, so then we say 17.52 meters is the distance of the man from the tower. I'll just cut it short. From the tower. Okay? So again, we use tangent because the given are the legs opposite adjacent. And then we just simply substitute the values that we gathered from the data. And then do a short mathematical computation. You may use your calculator. And then you have the final answer, 15.52 meters. Another example, suppose that when the angle of elevation of the sun is 63.4 degrees, a building casts a shadow of 37.5 feet. How tall is the building? So then again, you have to be imaginative in this case because, again, not all problems will give you the direct illustration. So you have to be imaginative. You have to use your creativity and imagination for you to see which is really which. You may draw you may draw sketches and then try to check later on. For instance, in this case, let's try to consider this illustration here. So, if you see there, mag-imagine lang ka, pag-right ka o building. So, let's say, naka-building dari, kanino building, and then the sun is up, babaw niya. Okay, of course, mukas mo siya shadow. So, dili po dari sa pikas. Pwede naman i-draw some like on this side, pwede sa diha. So long as makakasya og shadow. So, the 63.4 degrees is actually in this angle here. So that is the angle of elevation. So that is 63.4 degrees. And this one is 37.5. Now, what is being asked is the height of the building. So this part here. Let's change the color. So this part here is being asked. That is, let's say, consider that one as, let's say we use y na po. Let's try to use y na po. Again, this angle is 63.4 degrees. So then again, you have to assess the given of your illustration or the problem. So you have here the angle, the reference angle, and check the relationship of these sides to the angle. This one is the opposite, and this one is the adjacent. So you have the opposite, you have the adjacent. So as part of one of the reminders a while ago, if the legs are given, you use tangent. So we let y be the height of the building. Okay. So then, as established, we use tangent theta because the given are the legs. That is the opposite side over adjacent. So the theta here is equal to 63.4 degrees. So tangent 63.4 degrees is equal to y, because y is the opposite. Adjacent is 37.5. And cross multiply lang. Tangent 63.4 degrees times 37.5 equal to y. You may write the y first and then get the product of the two. You have the tangent 63.4 is actually 1. How much is that? 997 times 37.5. Y therefore is 74.89. Hence, we say 74.89 feet is the height of oops of the building. Okay, hope that is clear. It's 74.9 feet, 74.89 feet. Okay, now the last example. Again, the ones we are using here are the concept from the six trigonometric ratio. So we only added the concept of the angle of elevation. Okay, a passenger on a ship observes a 1,800 high lighthouse that stands on a hill, which is 3,700 meters away from the ship. Find the angle of elevation of the top of the lighthouse from the ship. So take note that not all the times that the problem will be only asking for the length of one of the legs. No? It's possible that it will go around as well with the other variables, like the angle of elevation or the other angles that is indicated in the problem. So it's not always fixed on the idea that you're going to solve the same way, the same thing that I am giving you as an example. So the problem will always be dependent. No? The solution will always be dependent on what problem you're dealing with. It's looking for the angle, you have to solve it using the shift cosine, shift tangent, shift sine. In this case, we're going to use the shift because we are looking for the angle. Then again, you use your creativity and then for you to label. Take note the given here are the legs. Maybe the legs or maybe the sides. But these are measurements, not angles. So probably one of the legs. Let's consider this one. Here you have take note the lighthouse is 1,800 meter high and that stands on a hill. That's high, okay, 1,800 meters high. And this part here is 3,700 meters. That's the distance from the tower to the ship. So that is the height of the tower, 1,800, and then the distance from the ship to the tower is 3,700 meters. What we're looking for is the angle in this part here. Okay. Problem says, find the angle of elevation of the top of the lighthouse from the ship. So it's here. Okay. So we use let theta be the angle of elevation of the top of the lighthouse from the ship. So we have to check what's the relationship of these sides to the angle. So again, the height of the lighthouse is 1,000. It's the opposite of that angle, and this one is the adjacent. So you have there. We use then tangent theta equal to opposite over adjacent. Since we're solving for the theta, we cannot replace the theta with anything. So we replace the values. The opposite is 1,800 over the adjacent 3,700. So then we apply the shift. Okay, take note. Shift tangent, that will give you a tangent -1. Then you can reduce this fraction to lowest term and then input it like this. So what happened to the zeros? I just canceled it out. Okay. And then that will give you roughly theta equal to 25.94. So sir, we're talking about angles. Aren't we supposed to put this in a whole number? Well, since this is a problem solving, putting it realistically, we cannot just simply put it into a whole number. Okay? So pag problem solving, obliged tayo to follow at least two decimal points. Okay, in this case. Now, if just like simply plain problem solve ka to lang na shape, tapos mag-solve lang ka, pareha sa quiz. The test 2, 3, and 4, di ba? Your task 2, write the final answer in nearest whole number. In this case, we're talking about a realistic problem. So we have to specifically be close to what's the exact value. Okay? So it's the angle of elevation, therefore, is, we write it in sentence form, the angle of elevation of the top of the lighthouse from the ship is 25.94 degrees. So, I only prepared three examples, but hopefully you were able to follow the rest of the solution. If you have questions, feel free to message me lang. You can use the email or the messenger. I'll be providing you the formative activity for this one. I'll be using quizzes. Just keep posted. Thank you and adelante.